Alright, so got couple more assessments to do, but this is assessment number 7, my first video on, the assessment was equilibrium. We're talking about, kind of torque on a rigid object. What I have is I have, two people sitting on a seesaw. This guy right here weighs 525 newtons, and he is, 1.5 meters away from the pivot point, and then we have a lighter person sitting on the very end of the board, who weighs 455 newtons, and we want to first find out how far away the lighter person is sitting from the pivot point in order to balance the seesaw, and then we want to find out the normal force that's being applied upward on the seesaw. So what I did first was I drew a free body diagram. We know that each of the masses are going to be pulling down, as well as the mass of the board. And then we have a normal force going up. So the first thing I did is we know that because these people are in equilibrium, that our total torque is 0 newtons. We then can say that the torque in the counterclockwise position equals the torque in the counterclockwise. Is the person right here is a clockwise, and this person is counterclockwise. But anyways, we can say torque 1 equals to torque 2, and we know that torque is the force times radius. So what I did is we have the mass of our first person times their radius equals the mass of the second person, and we're looking for R2. So R2 equals to mass 1 times radius 1 divided by mass 2. You get 525 newtons times 1.5 meters divided by 455 is 1.7 meters from the board. So the lighter person sits 1.73 meters from the board. And then we want to find what the force of the normal force was. What we know is if you look back at what I had for the free body diagram, we know that F net in the x direction is 0 because there's nothing acting in the 0 direction, and then everything in the y direction cancels each other out. But in the y direction we have the two masses, they're both downward, so they're both negative, and then also the mass of the board going down and the normal force going up. So I solved for the normal force, and normal force equals to m1 plus m2 plus the mass of the board. So we get N is equal to 525 newtons plus 455 newtons plus 50 newtons. That's how much the board weighs, and the force of the normal force comes out to be 1,030 newtons. Like I said, there's assessment number 11 on equilibrium.